following radical products, square root products. There's a few different techniques to this one. My technique might be a little bit longer, but it's going to be much more powerful when you abstract processes with variables and such. So I'm going to stick with it because I do believe it's extremely valuable. So square root of 20, plus I think it shows a cute way of understanding radicals. So square root of 20 is, let's break it down into its prime pieces. 20 is 4 times 5, 4 is 2 times 2, 80, which is under the square root, could break down into 4 times 20, 4 is 2 times 2, and 20 is 2 times 10, and 10 is 2 times 5. Okay? Now, once it's broken down into all of its prime pieces, you can look for pairs that will escape from prison. Here is a pair of 2's, here is a pair of 2's, and here is a pair of 2's. So, what is the answer to the problem? Well, the 3 was always up here on the outside, so I'm going to write it first. The escapees from prison were a copy of 2 on the left, a copy of 2 on the right, and a copy of 2. Oh, I missed a pair there, didn't I? Look at that. A pair of 5's. So conveniently I noticed that. That's why this technique works really well for me, because then as I was getting ready to write out things, I saw that there was a 5 also. And that means, actually, funny enough, that nothing was left in prison because everything escaped. So there's no need for the prison anymore, and we don't even have to write in the radical. 3 times 2 is 6, times 2 is 12, times 2 is 24, and times 5 is 120. So it looks like the final answer to this problem is simply 120. Okay, just to see it again in case this is new to you, let's try 98. 98 breaks down into 2 times 49, and 49 is 7 times 7. 48 breaks down into 12 times 4. 12 is 4 and 3. 4 is 2 and 2. And 4 again is 2 and 2. Any pairs? Yeah, sure. There's a pair of 7's. There's a pair of 2's. And there's a pair of 2's. So, outside of prison, 2 times 7 times 2 times 2, 227, broke out. Square root of what was left in prison, the singleton 2 and the singleton 3, which did not meet up, so that's a 2 times 3. And so your final answer here should be 2 times 7 is 14, times 2 is 28, times 2 is 56, and in prison, 2 times 3 leaves us with a 6. So why don't you pause the video and try to do this problem on your own. 2 times the radical is 75, times the radical of 96. No need to do the prison way if you want to do it in a different way, but assuming you gave it a pause here and tried it, let's see what we get together. 75, 3 times 25, 25 is 5 times 5. 96, on the other hand, is 4 times 24. 4 is a 2, 2. 24 is 4, 6. And 4 is 2, 2. And 6 is 2, 3. There's all my primes all broken down. Pairs. Looks like a pair of 2's and a pair of 2's. I see a pair of 5's. And I also see a pair of 3's that match up in this multiplication. So all that's really left is that little 2 hanging out right there. So answer, 2 times the escapees, 3, 5, 2, 2, and inside of the radical, just that single leftover 2. So final answer, 2 times 3 is 6, times 5 is 30, times 2 is 60, times 2 is 120, and with a radical of 2.